Good evening. I'm talking about robots and food tonight. My name is Orfeo Nicolai. I'm from Switzerland. I had many roles in my past, working in the industry for about over 20 years as system administrator, as coder, as entrepreneur, as business intelligence, data science, whatever came into my hands that was kind of technology related. Worked in many companies. At some point, I came here to London to do a degree at an art school, which is kind of random, but was really interesting. I didn't want to leave afterwards, and now I'm at Karakuri, which is a startup that does robots for the food industry. I'm the head of software there, and I want to talk a little bit about Karakuri, that you understand what we do, because probably no one of you heard of us. And then I'll talk a little bit about the architecture. So Karakuri was founded by Barney Ragg and Simon Watt. These two guys met in the early days of ARM in Cambridge. Part of what they're responsible for is that you have multi-core CPUs in your phones. That was kind of their idea, and they worked on that. At some point they left there, ended up meeting again in the music industry, worked at Universal Music. Simon was the head of technology there for many years. About 1.5 years ago, they founded Karakuri. The idea they had is building a restaurant that is completely operated by robots. So they made fancy slides and renderings and talked to many people. On their way there, they gathered a team of few very smart men, but they didn't really push forward the concept of like something new, something like, tangible. So they gathered around a little bit a younger team. I was part of that. I don't know how young I am, still I am, but so they came away from the restaurant because the restaurant is too much of a challenge today. So too many unknowns, too many things to build at the same time. So they reduced their scope and can we build a machine that just assembles food? So a human chops it, fills the machine, and the machine just puts it on a plate. The idea is people want more customized food. They're aware about their nutrition, they care about their diets, they have allergies. But on the other hand, we see cities like London, more and more people want to eat at the same time over lunch, and the quality suffers. People just smash the food on a plate. It's like, you don't really get what you want. So they want to do a machine that kind of has mass production and customization in one thing. Kind of a tiny little factory. So that prototype they wanted to build, they got a team around, and we actually kind of managed to build something. That was pre-funding. We had no money. Most of us worked for just good faith and hoped to get some equity out of it. It's made out of cereal dispensers you find in hotel lobbies, kitchen scales we hacked to get the mass sensors, a robot arm from a London company called Automata, which is about 4,000 quid, which is very cheap for a robot arm. So we built this machine with including an interface. And it worked. We got some money, we got some pre-seed funding about 2 months ago. With that came press a little bit, and I guess still no one of you have read it. And now we have to build a big version of this machine that actually works in a big restaurant. So it's scary, but it's fun. And now the interesting bit. So that's why you're here. As I said, I'm head of software. I'm currently designing the whole architecture of this machine works. So this is our prototype, or at least the rendering of it. I want to take it apart with you and explain how it works and how it relates to the bigger machine. So on one hand, we have these dispensers. In the first machine, they're cereal dispensers, plastic. We put an Arduino on. We had a stepper motor, a scale. But in the end, it's just a tiny machine that dispenses one ingredient. We have an arm that is, in the end, just some machine that moves vessels around to get the food in the same place. We have some sort of interface to talk to the machine, and in the middle is some sort of brain that coordinates everything. For a big machine, software, it is kind of the same. Instead of a cereal dispenser, it is a stainless steel industrial grade machine, but the only thing is I want to talk to it and say, give me some food. So yeah, early on the question about, do I build a big brain in the middle? Do I take everything apart to the extreme? And yeah, kind of that's what the manager said. I choose a solution that is kind of microservice based, because on one hand, we had to process very fast. We had daily changes in our architecture from a hardware side. I'm working with some very talented mechanical engineers, with some very talented food engineers. They have new ideas every day. They come to problems they can't solve and have to change things. And me as a software guy, I have to kind of do the stream next to it that keeps the whole thing running. So I try to take everything apart. One thing I wanted is a backbone, kind of a universal language where everything talks about. And I choose RabbitMQ as my service, or AMQP as a message protocol, which is kind of, that is my contract with all the parts. Let's start with the ARM. I'm a software developer. Suddenly something moves if I hit F5, which is quite scary. I knocked over my coffee cup. I made a hole in the wall. It's not as safe as software development if you have a machine that moves around. But it's also fun because it's a new challenge. And it has also something else, is you start learning, you interact in a physical world. Software, everything is fast. It's based on the frequency of your CPU. With hardware, in a physical world, you suddenly become very, very slow in software terms. You have plenty of times. 500 milliseconds? Who cares? Like, no one cares if that grip opens or closes a little bit faster, at least not in the applications we're in. So that gives kind of new freedom of how to design a software. It's not about how do you deal with concurrency, how do you do waitings. That's all pretty easy. So they have to talk. We have this quite very slow physical system. So JavaScript was quite an interesting decision, because JavaScript is very good in I/O-heavy applications. That's why it's used in a browser. We constantly wait for a user to click on something, or a browser to send us a push notification from a service. So that was actually quite an interesting choice. Most of the robotics companies, they set on Python, because Python is what they teach you in universities. That's what you use when you do robotics. But I found JavaScript is actually a few better attributes, components that work with robotics really well. So in the end, what I started doing is creating very simple processes, very, very clear interfaces. So for the ARM, I wrote two classes. A service, which just listens for AMQ messages, ARM move. That's its only input it takes. And it has one function that says move ARM from position A to B. So if I want to replace the hardware and change the ARM, I have to change some code, but my interface stays the same. The machine doesn't care if this is an ARM with 6 joints or if it's a conveyor belt. My contract in the software stays. My whole system keeps working. Doesn't matter what that part does. And obviously, we got a bigger ARM. The one from Automata was really good to prototype because it was cheap. This is a company called Universal Robots. They do industrial-grade machines. You see them lots in automobile factories, in other factories. We had a party. We used it to put some spices on cheese. With the dispensers, very similar story. We have the serial dispensers here. Now we're working on kind of more industrial grade stainless steel. We're a little bit further than the renderings. We actually have prototypes. I think of the latest, I don't have pictures. But same story here. I need an interface. I want the machine. I have my architecture of the whole system. Use Node.js again. My future goes, JavaScript go away. Machine, please talk to my AMQP directly. That's a super interesting challenge we're working on, is because the dispensers, they're our components. That's the one we develop. The ARM, we buy in. So we have the chance to make these talk straight to our architecture. And then, yeah, we have all the different brains who does do sequencing of what to do next. We have a brain that listens for logging, just for us to kind of have a monitoring. We have messaging that goes out if you have to refill something. So we can make all these little services and just attach to them. And obviously the communication bit. So we're in a kitchen, we're in an environment, we want to do customization. So where does this user input coming in? And today, I guess one of the big ones is Deliveroo, Uber Eats, these kind of services. And if you look at their business model, they go to a restaurant, they give them a tablet, and it's like, here you can get your orders in. And then if you go in a restaurant and look at the kitchen and the counter or they have the till, they usually have 2 or 3, 4 tablets because each of these delivery company puts another tablet there. So Deliveroo recently started offering an API, which is quite hard to integrate actually, because you need to have a public-facing service as a restaurant. And we see how digital restaurants are at the moment. So this is a big challenge we have. How do we integrate our machine into these ecosystems? So the Deliveroo part, that we can do. How do we go into an EPOS system? These are other challenges. Again, Node, we're here in the JavaScript world, that's why I'm here. Express, at the moment it's a REST API. I'm currently going to more a GraphQL way, hopefully finding a way to kind of merge the little bit old-fashioned system of the gastro industry into a little bit newer level. And we want these machines to talk to us because they have to optimize. We have to update them, so we kind of need to get our sort of backdoor to go into it. And we want to connect them to all these services I called about before. And in the end, we have multiple restaurants. We want them in multiple different places, and we want them to talk to each other. Because our customers, we focus on a mostly casual chain restaurants. So how do they talk to each other? How do they get to know which place produces how much of what, that they can optimize their ordering? And yes, who thought that would be Node.js? So where are we going from here? So at the moment, everything is quite like algorithmic driven, very pragmatic. It's on a prototype level. But let's take the dispensing for an example. Having ingredients like kale or broccoli or fish cubes, these are quite challenging things to dispense accurate. So you find in the food industry, you find like big machines, they kind of take it apart, put it in hundreds of buckets. They know the weight of each bucket and mix to get the result. But that needs a huge space to work on. So what we want to do is go on a tiny space. So one of the big challenges, how can we make the dispensing accurate, straight in on a plate? And yeah, computer vision is a great thing we're working on. So with the professors we have in our advisory board at the universities is something we're really interested in, kind of looking at the food that's coming on a conveyor belt, recognizing what's coming, and therefore control the speed and the momentum of these conveyor belts to dispense straight into a plate. And these are super interesting projects. At the moment, we're on the very side of the plate. We get chopped ingredients, humans prepare most of the things, but we want to go back. Because what we can do is we can track exactly what people eat, how they manage to do it, how much ingredients the restaurants need, therefore want to predict how much they need to order, how they do their stock management. And that's a really good idea to go further back and help to get the logistics part in. I think our partner, our sponsor or investor, Ocado is a great partner to do that. And talking about the future, I hope some of you may be also here. We have some jobs open. Thank you for listening. And now keen to